is the introduction of four-band inductor. The main difference between color code resistor and color code inductor is their surface color. Its surface color looks green, not blue or light brown. It's an inductor. This is a color code table of inductor that we can know the inductance by its surface. There is an example. First band means 10 digits, and you can see that red denotes 2. Second band means unit digits, and you can see violet denotes 7. Third band means multiplier, and brown denotes 10. Fourth band means tolerance, and gold denotes 5%. It's RL series circuit. We want to know the difference between source voltage and voltage across inductor. Use the equation below and parameters given. Imaginary number J will cause 90-degree phase shift. That is the reason why inductive reactance is always with positive 90 degrees. Then we can calculate the inductive reactance. Here is the step. Second, calculate total impedance. We can calculate it the same way as calculating the total impedance of RC series circuit. You can see the equation looks similar when calculating magnitude of impedance in RC series circuit. Also, the same way to calculate the phase of impedance. The only difference is their definition of phase of inductor. Then, we will get a normal form of total impedance. Here is the step. Third, calculate voltage across inductor. The equation below is to calculate the voltage across inductor, where VL denotes voltage across inductor, and Vs denotes the source voltage generated by synthesized function generator. Because we use source voltage as time base, the phase of source voltage is 0 degree. Then we can calculate VL. Here is the step. When finishing calculation, wire follow diagram and use synthesized function generator to verify. This is RL series circuit without connecting to oscilloscope and synthesized function generator. Then we begin wiring. We connect synthesized function generator first. Use oscilloscope channel 1 to measure source voltage. Use oscilloscope channel 2 to measure voltage across inductor. Voltage across inductor is about 0.532. And phase difference between source voltage and voltage across inductor is about 58 degree. Try to make the amplitude of VL equals to 0.25 Vs by calculating and adjusting source frequency. Follow the steps. First, use equation of voltage across inductor. Then we can get the ratio of reactance and impedance. Here is the step. Third, we can calculate reactance. Here is the step. Finally, use equation to calculate frequency and you can adjust the source frequency to observe the difference. Here is the step. You can see VL is approximately 0.25 Vs. Try to make the phase shift between VL and Vs to 45 degrees by calculating and adjusting source frequency. First, use equation of voltage across inductor. The definition of phase of source voltage is 0. Second, we can know that phase of inductive reactance over Z equals to 45 degrees as question. The definition of phase of inductive reactance is 90 degrees. Here is the step. Third, we can get the phase of impedance Z, which is also 45 degrees. Here is the step. Then, we can use the equation to calculate the reactance. Here is the step. Finally, use equation to calculate frequency and you can adjust the source frequency to observe the difference. Here is the step. You can see phase difference between source voltage and voltage across VL equals to 45 degrees.